we're going to do. And so as Rob said, we're going to do slides for maybe 10-15 minutes. I'm going to give a Pegasus overview, talk a little bit about the different components of a Pegasus workflow, abstract workflows and catalogs. I'm going to talk a little bit about common workflow transformations and how to debug and get statistics out of your workflow run. Then we will switch over to demo part where we're going to run, first a simple workflow. We're going to have one with a failure. We'll see what the failure shows up as. We are going to show the OSG Exceed example, for lack of a better name. It's more of a real-world example that's good to base your workflow on. And if we have time, we're going to look at task clustering and data management. And I also want to say that this presentation is aimed towards the campus Condor pools and OSG. So there's OSG and Condor pool specifics. Pegasus has more capabilities than that. For example, you can interact directly with grid sites and services like GlobalScram and things like that. I'm not covering them today in this presentation, but you should know that the capabilities are there. So what is Pegasus? Well, it's a workflow management system. It's been around for a long time, 10 years plus. And it's a collaboration between us here at the USC Information Sciences Institute and the Condor team at UW-Madison. And it's tightly coupled with Condor Dagman. Pegasus workflows are the core of a Pegasus workflow is Condor Dagman, and thus we inherit the same kind of capabilities and the same kind of feature set that Dagman has. We just add to it. Important to note that because this is DAGs, directed acyclic graphs we're talking about, you can't do things like loops or conditionals in the workflows. The DAG is fully defined, and if you want to do conditionals, then you have to probably do hierarchical workflows. An important concept of Pegasus is the notion of an abstract workflow. This is the input description that the user provides. That's what describes his computation, and it is a higher level language. But what's important to understand about it is that it's a format that was designed to be able to allow for sharing and portability of these workflows. So what that means that your description, the abstract workflow, does not have things like data locations or executable locations. That's those kind of pieces of data are brought in later on when you plan the workflow. The core component of Pegasus is the workflow planner mapper. And what that takes one of these abstract workflows. It does transforms, it adds nodes to it, it can remove nodes, it can cluster nodes together, things like that. And there's many reasons. Reliability is one, performance is another one. And it takes the information, the physical locations of these files, input files and executables and things like that, and creates an executable workflow that you can run on your resource. Another important feature is that while that workflow is running, Pegasus is collecting provenance information. So that includes where the tasks ran, it includes run times and environment and debugging information. There's a lot of information that's collected during that step. That allows us to provide debugging tools and statistics tools and things like that. So my point with this slide is that workflows can be simple. And when the workflow community talks about workflows, we like to put up graphs with really complex DAGs with a lot of job dependencies and data dependencies and things like that. And I want to make sure that you understand that even though if you have a simple workflow, even no job dependencies whatsoever, it's still a use case for running it through a workflow management system, because you still end up with the reliability and the provenance information and all that stuff. So there's a lot of features of the workflow system that you can use, even though you have a fairly simple workflow from the workflow community's point of view. And actually, that's one of the most common use cases we see on campuses and OSG. That bag of tasks, things like parameter sweeps, is very common. So here's the system overview of Pegasus. We are on the left there. We are the users. And we can interact with Pegasus in different ways. The most common one is API. This means that we're using provided API to design our workflow. You can use portals. We have done a lot of work with the Hub, Hub Zero and NanoHub, NEAS and those hubs recently to get Pegasus working well behind the hubs. And you can also use more graphical composition tools, Grayson, Triana, and Wings. This talk is focusing mostly on API tools, and it is the most common one, mostly because it scales very well. If you want to create a workflow with 1,000 tasks or 1,000,000 tasks, well, doing that in a graphical editor kind of gets old pretty quickly. But those tools are available if you want to use them. And in the middle of the picture, we see Pegasus has the mapper and the scheduler and monitor, all that stuff. And the other two on the right and the bottom, well, that just shows that this workflow, the abstract workflows, can be planned to different resources, and depending on what's available to you, you can use Condor pools or grid resources or cloud and national infrastructures like Exceed. So there's a lot of options on where to actually run these workflows. So I said abstract workflow is an important concept. Here's an example of that. On the left, we see a workflow with two tasks. It has an f.a input file, an f.b intermediate file, and an f.c output file. And the arrow indicates what the planner does. That's the planning step. And what you end up with is a more complex workflow where Pegasus have added in nodes to that workflow. And in this case, we see there's on top there's a create directory node. There's a stage in of the input file. After the nodes, there's cleanup jobs. As the workflow progresses, the data is cleaned up, and that's to maintain the smallest possible data footprint. There's a stage out node almost at the bottom, and a registration, and then a cleanup job. These what the planned workflow will look like is different, but depending on what resource you're planning against. This example here, I think, is a grid resource where you have a shared file system. If you want to run on a Condor pool, well, it might look different. The planned workflow will look slightly different. So I said the abstract workflow is site independent, but there are catalogs that Pegasus needs that are site dependent. And there are three of those. There's a site catalog that defines the execution environment. The site catalog, depending on what resource you're running, it could be simple or complex. In our case, we're running against a standard Condor pool. It's very simple. We just, it's almost just a placeholder. Well, if you're running, for example, a grid resource, you have to specify endpoints and service endpoints and things like that. There's a transformation catalog, and that one defines where the executables are. If you say that I need use one of your executables, you have to tell Pegasus where it's installed or where it can be picked up for staging if that's the preferred method. And replica catalog last is the location of data products. And when the workflow starts off, well, the replica catalog should at least have your input files. Right? We need to know where to pick those input files up. But as the workflow progresses, this replica catalog is updated with locations of output products as well, and that allows us to pick up those products later on or for other workflows, for example. Pegasus has three major data staging approaches. I'm just going to cover the two first ones here today. The third one is more for the traditional HPC systems, which we're not covering. So there There's a non-shared file system, and that means that's what we see on Open Science Grid. There's a set of machines all over the place. There's no shared file system or anything shared between those nodes. So data has to be pulled and pushed from somewhere. Condor I/O, well, that's the standard Condor file transfer mechanisms, transfer input files and transfer output files. And this is an easy to use method, and it's great if all you want to do is stage files to and from your submit host. The non-shared file system on top is a little bit more generic. It will allow you to select a different site for example, for being the staging site. So this is what a workflow planned on OSG or executed on OSG could look like. On the top left, we see there's a workflow, an abstract workflow that gets planned down and into executable workflow, and that's what we see down here. If you see my cursor, and so you see there was a few jobs added. There's an extra circle around those jobs in the executable workflow, and what that is that Pegasus have wrapped these executables. It wraps them with something called Kickstart to collect provenance information and some staging things. On the right, we'll see, or the big picture here, we'll see what that workflow looked like while it's executing. On top right, we'll see data getting pulled into the staging storage element. We see the magnifying glasses. They show a zoomed-in view of the job executing that site. And this is, we call it Pegasus Lite. It's basically a mini workflow contained in a bash script that pulls in the data from a remote site, runs the computations, and stages stuff out. And doing this way, it's very generic. We can basically throw these little things on any compute node available to us, and it will just work out of the box. I mentioned that Pegasus, the planning step is the most important Pegasus step, and it can do stuff for performance, or it can restructure workflow for performance or reliability. And in this case here, it's performance. This is clustering of smaller tasks, and there's two reasons for doing this. One is you have the jobs are short. And what short means, it could be a couple of minutes or 10 minutes or half an hour, something like that. Maybe less than an hour. That's a short task in this context. And so by clustering them together, making a longer task, you will be able to hold on to the resources that you use longer, and you will get overall better throughput if you have a big workflow. Well, the other reason for clustering the data together, the tasks together, is that if they have common input data, you will be able to like Pegasus will know what data is needed for each task. And if you have a common set, well, you only have to transfer that once for that cluster of tasks, and so you will get less data staging by clustering them together. Another common transform is workflow reduction, and this is common if you have workflows that, for example, overlap. If you run a workflow every day and part of it is overlap from the previous day, which means that you might have data products, partial data products from a previous day or previous run of that workflow, that means that you don't have to rerun all the computations. And here's what Pegasus does. It looks in that replica catalog, and if you have data products that it needs that already exist, well, it will start reducing that workflow to remove the unnecessary computations. So in this case, we start with the workflow on the left. Pegasus notices that f.d, that file, that data product already exists, and it walks backwards from that data product, removing the unnecessary computations. And what we left with is a simplified workflow on the right that only runs the computation that are actually required. And I also say that there's a lot of other transforms. Those are the only two I'm covering in this talk. There's a lot of there's a good cleanup algorithm that maintains the file system usage, and there's different types of clustering, for example. So there's a lot of different options, but those are two major ones that covered today. So I did mention that as the workflow moves along, it collects all this provenance information. There is and this is all done automatically also, but there's basically a database that gets populated. It has things like workflow structure, runtime stats, some debugging information. And then we provide a set of tools to bring out information from this system. There's a Pegasus status command that's used a lot, that's used at runtime to see the current state of your workflow. What's the progress? What's the percent done, for example? There's other one called Pegasus statistics that provides that's what you see at the bottom of this slide. After a workflow is run, it will bring out and it will show you, for example, wall time of the workflows, the cumulative wall times, how much computational resources you actually used up, and failed tasks, retry tasks, things like that. And there's a Pegasus plots, which is more a graphical kind of version of that shows Gantt charts and pretty pictures of how your workflow ran. And that's what this slide is showing. Excuse me. On the bottom left, you see a web page view of this. This is a new tool that we shipped in Pegasus 4.2. It's still kind of in a beta state. It's called a Pegasus dashboard, and it's a interactive web app that you can browse your workflow statistics with. The other three graphs, the top ones and the lower right, are from the Pegasus plots command. Depending on what your workflow is running, I mean, these will be, can be, different degrees of interesting. Sorry. For example, if you're running a bag of tasks or just independent jobs, well, a Gantt chart or one of those are not going to look very interesting. If you have structured your workflow, well, you can use these charts to see where if there's a bottleneck or something that's misbehaving. If you see weird timings, for example, on tasks. The workflow debugging, that's the Pegasus analyzer command. And if you're running a lot of workflows, this is, I think, probably the most useful of them all. What it does is that it will, if you have a workflow that fails, Pegasus Analyzer will show you where it failed and what the standard out and error code and all that stuff was for that task or for the task that failed. And it's so it's incredibly useful, right? I mean, instead of grabbing through log files and trying to figure out and backtracking, all that stuff goes away with Pegasus Analyzer. It's very nice to just be able to go and query and saying, hey, where did this fail? All right, so that's all for the slides I have. A couple of websites. There's the Pegasus that I cited EU website. There's the tutorial and documentation. In our documentation, there's a tutorial chapter. And what that is, it's not exactly what I'm showing today, but it's a self-guided VM. So you download the VM, you can run it in VirtualBox and VMware, I guess, and step through and learn about workflows by just doing the self-guided part. It's a nice way of self-guided tutorial. So let's switch over to the demo. But or first, anybody have questions about this? Any questions on the slides?
So everyone should be able to speak. All presenters should have microphone rights, but if you're trying to speak and right now we're not hearing you, just please let me know. Okay, we have Kevin Thompson's typing a question. Folks can still hear me, correct? Hopefully?
Yes, I can hear you.
Okay, great. Okay.
Yes, so Kevin is asking if there's a URL, for example, Pegasus dashboard. Yes, there is. The easiest way for you guys to get to it is if you go to the webcast. Where did that go? The webcast. So this is the page that is on campusgrid.org for this talk. If you go down and you find a URL and you click that one, there is some details about this talk. The slides are available. There's a tarball of the workflows that I'm going to show soon. A picture of one of the workflows. And if you go all the way down to useful links here, here's a dashboard instance. And well, I can show it here quickly. It doesn't matter what order I'm doing this in. What is it? All right. So the workflows we're seeing here, these are from some nightly tests that we're running on Pegasus every night, and this is a test instance in general. So for example, like here's like overall for the workflows in the database, if they have failed or how many are running, what failure and success rates. So we have about 11,000 workflows in this one. And there's a few that failed, but that's expected. As I said, this is for our code coverage testing and things like that. If we start drilling down, we can pick one of the workflows here. Well, we can do Diamond. This is one that we're doing later. It's a small workflow that only has 4 tasks. We'll see, successful and failed, a little bit of statistics on how long time it did take to run it. We will be able to see some charts of the job, the Gantt chart of the tasks, for example. Count the runtime. So these are simple workflows. So it's not, there's not too much to be learned from them. In this case, for example, it's interesting to note that we spend more time doing transfers than actually computations. Again, in a real world workflow, you wouldn't see that, but that's for testing purposes. I'll come back to this a little bit more if we have time at the end. But yes, you can browse this yourself if you want to spend some time on that.
So Mats, before you go off to your command line, I just had a sort of a general overview type question. So when you're talking about Pegasus here, you're and all these capabilities, I can see this coming into the end user directly, and I can also see this as someone on a campus running a campus infrastructure and is supporting different users might do some of the legwork here in terms of setting up a Pegasus launchpad. So, for example, your site catalog and the other components in there, the bits of infrastructure around Pegasus. So, is it easily set up so that you can sort of choose either one of these modes? It's like the equivalent, the analogous in the Bosco space is Bosco for the end user, where it's very direct, where you grab something and you're submitting to campus clusters, right? But you can also run Bosco as a service, so that someone running and who's doing sort of the testing or sort of running a facility on behalf of many users might be running Bosco as a service.
Yeah.
So, do you have the same model here for Pegasus?
Well, so first we have spent a lot of time to make installation and usability, better and better, right? There was a while where it was harder to install and harder to use than it is today. So today, and especially for OSG systems, it's an RPM install. It's 1 RPM install, and so if you already have a Condor submit machine on your campus, or if you have a Gliding WMS submit machine or a Bosco submit machine, well, Pegasus is just a YUM install away. So that takes care of getting the bits in the system. The second thing you're saying about the site catalog, if there is something that the site can do, well, they can maintain the site catalog, and I will show two different methods of that in the hands-on. But basically, what it comes down to is that you can either use a static site catalog for your site, or you can generate it on the fly, and kind of both depends on what your users are doing. The site catalog, like it kind of it can be shared. It's designed to be shared, but there's also a lot of times where a user wants to tweak something, saying, "Well, I don't like where this data is stored," for example, and if that's the case, they might need their own site catalog anyways. One of the examples I'm going to show here today. And I'll actually just do that now as well. If we go back to that URL here, that URL, there is something called the OSG Exceed workflow example. Okay, and this is something that we wrote up on it's probably 6 months ago, but this is more for the sites that those sites that wants to provide this for the submit sites that wants to. And so what this has is that it walks through the Pegasus workflow. It has a tarball here, if I can find it. Here it is, where you can download it, and it's a self-sustained or self-contained Pegasus workflow that you can use as a starting point to get your users going. And this is one of the ones I will be showing here on the command line. So I think, Rob, if let's go through with the command line one, and if you still have questions about it, we should raise the question again after the hands-on.
Sure.
Okay.
Absolutely. We got another question here from Mihai. Type something in the chat box there.
Feel after using Pegasus. Okay, so Mia says, what are the 1 or 2 ahas that the user feels after using Pegasus? Well, I think that the two biggest ones is probably data management, because it's obviously something you can do yourself, pushing the data back and forth in your jobs, but having somebody else do it for you, that makes your life so much simpler. And the other thing is the debugging tool. I mean, it's such a useful capability, and especially if you're running a lot of jobs, right? If you run 1,000 jobs and 1 or 2 fails, you don't want to dig through all that pile of log files to just find what happened. So I think like the debugging capabilities and the data management are the two big that people are really happy to see Pegasus take care of. Okay, so I will start the hands-on here. How much time do I have? I have 10 minutes. Is that what I have?
Yeah, you've got 10 minutes, and then we'll take some final questions.
Okay, so I am going to do the quick version of this then. So what I have here is this tarball that was on that download link, and I'm not going to do them all, but I'm going to start with one, which is the black diamond workflow. And the black diamond, comes from the shape. Let me see, find it here. So black diamond, this is a kind of reference workflow, testing workflow that we use a lot. So it has one process up front, pre-process task. It has 2 tasks that are in parallel, and then 1 analyze task that's dependent on those 2. And the executable in this case is called something called Pegasus Keg. It's just a example. What's it called? It's a reference application that's included in the Pegasus workflow. So this workflow doesn't really do anything except pass some files along. So what we will do, what I want to show you is in this directory we have a set of files, right? There is a blackdiamond.py, and this is our DAX generator. This is the part of using that API to define your workflow. If we look what's inside here, well, it's using a Pegasus API. It creates a abstract DAG. It adds a couple of jobs, and these are again the abstract one. We have a job that's called pre-process, but there's nothing in here that tells us what executable that means or where that executable is. We add a find range jobs and the arguments for those. You also see that there are uses statements about what data is used for each step. And at the end, we add the control flow dependencies. So these are the edges in that graph, right? Like, what task depends on what other task. Okay. And that's it. So that what that does, if we run this one, and we put it into the Black Diamond DAX, we get the Pegasus abstract workflow. And what that is, sorry. So this is XML. And if you already have a tool chain, you can actually generate this XML directly. You don't have to go through our APIs, but it's still helpful to do so. So something I recommend doing. So this describes again the workflow in an abstract term, and what we need to add to this mix is the catalogs, and these are replica catalog that's here. We have the transformation catalog that's here, and the sites.xml that's here. Right? The sites catalog. We start with that one. Again, that's XML. It describes two sites. You always need a local site, and this is where your local file systems are, right? Like your scratch space and your output space. The site for the Condor pool is super simple, right? There's no file systems defined. In this case, all it's saying is that we're going to run vanilla Condor jobs, and we have added one key that's called a project name, and that's site specific in this case. It's not something you have to do on your own Condor pool. Okay, if you look at the replica catalog, well, there's one entry in there, and that's the input file, f.a. And so we're telling Pegasus that f.a, it exists as a local file, and here's the path to it, and it's on the local pool. These replicas can be, as complex as you want to make them. You can say that the files already exist on a remote site or some other storage element. I mean, they can be almost anywhere. And Pegasus, as long as there's a URL or a file transfer protocol that Pegasus can handle, which there's a bunch of them, Pegasus will just pick it up and run with it. So if we plan this, so now we have there's some other stuff in here, sorry. There's the Pegasus RC, which is just a setting file, but this is all the files that we need, right? So let's plan this. Right, so this is the Pegasus plan command line. It takes, there's a bunch of options in this case. Where's the configuration file? What work directory do we need? What site do we run around this workflow on? This is what ties the abstract workflow together to the site catalog, for example. Where do we want the outputs to be? Local in this case. And what's the DAX name? So if we plan this, blah, blah, blah. Okay, Pegasus says, okay, we have planned this in this directory here. And this directory that's mentioned, well, this is the handle to your workflow. What that means is that Pegasus commands, instead of taking a job ID, for example, to refer to a workflow, we take a directory. And the reason for that is that the directory is valid before and during and after a workflow is run. So for example, after a workflow is run, you want to run statistics, well, you use this directory for the statistics analyze tool. So what it tells us to do is to start the workflow, just do this Pegasus run. So well, don't we do that? There we go. Apple C, Apple V. Okay. And Pegasus tells us that if you want to monitor it, here's a command to do it. And if I just could copy that. Again, the reference that directory is the handle to our workflow. if we run Pegasus status, well, this is almost you know, a Condor queue extension. It will show us what jobs we have here, what the state are, and it will show us a summary of tasks, if they are ready to be run, if they are in the queue, if they are done, failed, percentage done. If I run this again, see if there's any more jobs. Well, now we can see that there's some initial setup jobs going. Okay, while that's running, I'm going to switch over to this other workflow because I am running out of time. I just want to show you, I'm not going to run this one. 04 OSG exceed. So this is the workflow that I said this is a kind of a common one that we give to end users. This is the one that's mentioned in that OSG exceed write-up. And what's interesting about this one is that some of the some of the catalogs, for example, replica and transformation catalog, are in the DAX. So the DAX looks a little bit different. But this is, if you always generate a new DAX every time, well, you can put stuff in for convenience into the workflow, into the DAX. For example, here's the replica catalog, and this is actually replica and transformation catalog in one. So this is kind of a convenience way of doing things. We also usually give people a submit wrapper. And what that does is that it generates things like the site catalog on the fly. So this is an easy way for example, support staff at the site to give a user something that is kind of site specific. But if, for example, if you see here, they substitute things like the username, and it's so the workflow will work out of the box for any user on that system. And we also have things like Pegasus plan at the bottom, so the user doesn't have to remember, you know, how do I submit this workflow. All they have to do, right? They get this workflow from their you know, coders or their admins. They run submit, and the workflow starts by itself. Okay, so that's you know, the black diamond I showed first is kind of like the showing all the components. This is more of a you know, what you know, real world workflow would look like. Let's run Pegasus status, and let me see if the first one has finished. So the diamond is still running. So why don't we do some questions, or if there are any, and we can come back to checking this at the end. Are there any more questions? Just Rob, does this actually answer your question about what a site admin would do?
It does. I think what's kind of interesting here is just in terms of supporting users or introducing this to users is to have really straightforward templates that you can just easily modify. In other words, you can take the example templates. I think that's what I saw in the files that you were looking at. I mean, without having to know too much about the specific syntax and so forth.
Yeah, I'm running out of time, obviously, but in this OSG example, the idea is that there's this input directory, right? And what the user would do, let's say that you want to do you know, protein folding or something, he would dump his inputs in here, right? And the DAX generator would just generate the tasks for these. So the idea is that you would be able to write this, give it to the user, and when the user has a new set of inputs, it just puts them in inputs and submits a new workflow, right?
Mm-hmm. Here's another question I had while you're talking. When I've looked at Pegasus and you know, DAGs and so forth, it seems like a very useful use case is like a scatter-gather type use case. I mean, a lot of our users have their jobs running individually on lots of different nodes, writing individual outputs to some place, and they need to combine all these things up at the end.
Hmm.
And a lot of times what they're doing is they're writing scripts to do this manually. So that seems like a popular use case that could be, that's right up Pegasus's alley here, I think.
Yeah, and you're right, and that's also why I have that simple workflow thing in the beginning, because one of the things that we see a lot, or a lot of users that we end up meeting, they they end up with growing their computation over time. So they start with like a few jobs, and then when that gets too hard to manage, they add a DAG around it, and then when that gets too messy, then they write some scripts to monitor that, right? And and we see a lot of that where they were like, well, if I just could post process this, and usually that's like a manual step, right? They ran the workflow and then they go in and grab through things, and and that's very easy to do in Pegasus, right? That is that simple workflow I had with just one node that has all the computational nodes as a parent. It's very easy to do.
Mm-hmm. Okay. Okay, so Miha's got another one here.
Yeah, so yes, so Mia says, did I read this well? You calculate word frequencies of all those libraries in 3.5 seconds. Well, the workflow is still running, so no. But this is an example workflow, and it will run really quickly. Actually, it just finished. Now we can go in and see it. Let's go and see how this did. So what we do is we go into this directory. Sorry. All right. So this is what the run directory would look like. There's there's submit files and outputs and everything is in here. There's the DAG, for example, is here, right? So this is for people running DAGs and Condor jobs. This should look very familiar. So if we want to see, how well did this workflow did, first we can run Pegasus status. And by the way, if I'm already in a directory, it won't, I don't have to specify what directory I'm referring to. It just picks up the current one. Okay, so it's done, 100%. We can run Pegasus Analyzer to see if there was any failures, it would tell us, and nothing. Okay, we can run Pegasus Statistics to get some runtime statistics on this one. So in this case, it says that the wall time was 3 minutes, but the actual computation time was only 10 seconds. And this is backwards, right? If you're doing a real computation, the cumulative job wall time will be much bigger than the wall time of the workflow, right? Because you do tasks in parallel. We can also run Pegasus statistics and tell it to do a more full summary. And what happens is that in statistics directory we will get breakdowns, so we can look at for example different per task, how well did it do. And if you look at the WordFreak task, we will get the minimum. These are in seconds, so it's the maximum and the mean. So it's 0.1 second mean for those tasks. Again, if you run a real workflow, it would be more interesting numbers. But this is the kind of information you can get out of the provenance data that's collected.
Wonderful. Okay, more questions. Now's our chance, because we have Mats on the line. We can take advantage of the situation here. I have a lot more, but... Okay. Anybody else going to go? I'll ask one. Ava's typing something here, but let me ask you one while she's typing. So what I see really interesting about this is we have a lot of users who have very complex scripts and doing various things. And what this seems to, and they're more or less, let's say, I wouldn't say sophisticated users, but they're people who are versed, in Bash and tools, and they compute, right? So these are grad students and so forth, postdocs. What I see this as a way to sort of introduce them to something that is more, that gives them more of a standard framework so that they can pass something along and get a better insight as to what they're doing. So, for example, seeing the transformation statistics individually here is really nice because it sort of makes transparent what's going on behind the scenes that a lot of people will have to sort of infer from like parsing log files, or most of the time they're not as interested. They just want to get their job done, and they just look at the the cumulative wall time, but they might not know, for example, that their stage in is taking forever, that kind of thing. Mm-hmm. And if they were to just change their stage in strategy, they might find better performance. And if we're supporting these users, then we can, if they're in this kind of framework, we can inspect that ourselves if we go in and we examine. So I'm just thinking here as a way of what a good strategy would be to get some of these kinds of users on board, and how do we feed that, how do we lure them into this world if because it will take some recrafting and rescripting on their parts and so forth. I mean, is that part of your strategy here in Pegasus to sort of bring? I mean, maybe this is just go ahead.
Definitely. I mean, one way of looking at this is that we're trying to provide a framework that takes care of all the boring things, right? Like the data staging and the retries and error detection and things like that. And the user will still end up writing computational code, right? But he can spend more time on doing that instead of the low-level plumbing. So and how much you want Pegasus to do for you. I mean, it's still common to, for example, a user to provide a wrapper script. It still might, want to rearrange arguments and things like that. So, and Pegasus will allow you to do that. So I think it's very flexible, and for your use case where you're saying, like there's grad students and things. I mean, those are actually really good users for us. The thing is that if and I alluded a little bit to it before, that the further down you go that route, right, of creating jobs and a DAG and your own little tooling and things like that, the harder it gets to back that out again. So I mean, I wish that we could get people interested earlier on in their setup, right, when they are starting out or early on. If we can catch them earlier, I mean, I think they will have an even better experience.
Yeah. Okay, so Ava's got lots of chats here. So.
Yes, I have. First, you want me to show you how to get support, and what that is, if you go to pegasus.isi.edu, first there's a support tab, and what it shows you is there's a general mailing list, the Pegasus users mailing list, where you can discuss. You can subscribe to the announced list to get the announcement of new releases and other events. And there's also a Pegasus support list if you want to mail us, directly without it going to a list. For example, sometimes if you have a sensitive workflow or anything like that, well, you can reach us as Pegasus support as well. And obviously, I'm active in the OSG community, so feel free to talk to me directly. Next week we're at Condor Week. We're going to keep on talking about this at Condor Week. We have one Pegasus specific presentation, and there's a couple about Dagman and things like that. So there will be a lot of opportunities to grab hold of us.
All right. Do we have any other questions? Okay, thank you again, Mats, for this excellent presentation, and I think this is really interesting, and I'm interested to see how people on the call here or other people who are working in this area can pick some of these things up and start to support it at their campuses. I wanted to just make another reminder for anybody who joined late that if you go to the page which has the information for Matt's webcast today from campusgrids.org, there is a comments box there. So if you go to campusgrids.org and then webcasts, and you scroll down a little bit, you'll see a comments tab. And if you hit that, so as Matt's is doing right now, you can sign in with your Facebook ID and leave a comment. So I've just to show a couple of examples here, I've posted a couple of comments and I put some notes for myself on my OSG blog. So feel free to do that. Don't know why that's taking so long there.
No, you mean clicking?
Oh yeah.
Well, okay, well, I don't know. This is my wife's laptop, so we're probably logging in at hers right now.
Okay. Okay.
Anyway,
all right.
Yeah.
So there it is. Okay. All right.
Well, thank you for having us, Rob.
Oh, you're welcome. Any final questions? Okay. Thanks everybody for joining, and we'll see you